Welcome back to Kubernetes Crashcasts. I'm Sheila, and I'm here with Victor to dive into the exciting world of Kubernetes. Before we begin, I'd like to remind our listeners to rate our podcast on whatever platform you're listening to us. Your feedback helps us improve and reach more people interested in Kubernetes. Now, let's get started.
Thanks, Sheila. Today we're kicking off a new chapter in our Kubernetes Core Concepts season. We'll be exploring pods, which are fundamental to understanding how Kubernetes works. In this episode, we'll focus on understanding what pods are and why they're so important.
That's right, Victor. But before we dive in, I have a quiz question for our listeners. Here it is. In Kubernetes, can a pod contain multiple containers? Take a moment to think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's an interesting question, Sheila. It really gets to the heart of what pods are all about. I'm curious to see how many of our listeners already know the answer. For those who aren't sure, don't worry. We'll be covering everything you need to know about pods in this episode.
Excellent. Now, Victor, could you start by explaining what exactly a pod is in Kubernetes?
Of course, a pod is the smallest deployable unit in Kubernetes. Think of it as a wrapper around one or more containers. It's like an apartment in a big apartment building, where the building is your Kubernetes cluster.
That's an interesting analogy. So, if a pod is like an apartment, would the containers be like the rooms inside the apartment?
That's a great way to think about it, Sheila. Yes, the containers would be like the rooms. Just as an apartment can have one or multiple rooms, a pod can have one or multiple containers. But here's the key thing. All containers in a pod always run on the same node and share the same network and storage resources.
I see. So why did Kubernetes introduce this concept of pods? Couldn't we just work directly with containers?
That's a great question. Kubernetes introduced pods to solve several problems. First, it provides a higher-level abstraction that's easier to manage than individual containers. Second, it allows for co-located helper containers. For example, you might have your main application container and a logging container in the same pod. They can easily communicate and share resources.
That makes sense. So, Victor, could you walk us through the life cycle of a pod? What happens from the moment it's created to when it's terminated?
Certainly, the life cycle of a pod starts when it's created and assigned to a node. It goes through several phases. Point 1, pending. The pod has been accepted but isn't running yet. 2, running. At least one container is still running. 3, succeeded. All containers have terminated successfully. 4, failed. All containers have terminated, and at least one failed. 5, unknown. The state of the pod can't be determined. Throughout its life cycle, a pod remains on the same node. It's only removed when it's deleted or evicted due to lack of resources.
That's really helpful, Victor. Now, speaking of life cycle, I've heard that pods are ephemeral in nature. What does that mean exactly?
Great point, Sheila. Ephemeral means that pods are not designed to be long-lasting. They can be stopped, started, or replaced at any time. This is a key concept in Kubernetes' approach to application management and scaling. It's important for developers to design their applications with this in mind and not rely on individual pods sticking around forever.
I see. So if pods are ephemeral, how do we ensure that our applications remain available?
That's where higher-level Kubernetes objects come in, like deployments and replica sets. These manage pods for you, making sure that the right number of pod copies are always running. If a pod fails, these controllers will automatically create a new one to replace it. We'll dive deeper into these concepts in future episodes.
That's fascinating, Victor. Now, let's talk about some common misconceptions. What are some mistakes people often make when working with pods?
One common mistake is treating pods as if they were virtual machines. Unlike VMs, pods are meant to run a single application, albeit potentially with multiple related processes as containers. Another pitfall is not properly setting resource requests and limits for pods, which can lead to resource conflicts in the cluster.
Those are important points to keep in mind. Before we wrap up, could you share a best practice or tip for working with pods?
Absolutely. One key best practice is to keep your pods as lightweight and focused as possible. Each pod should do one thing and do it well. This makes your applications easier to scale, manage, and troubleshoot. Also, always use labels to organize your pods. They're crucial for effective management in Kubernetes.
That's great advice, Victor. Now let's reveal the answer to our quiz question. The question was, in Kubernetes, can a pod contain multiple containers? And the answer is yes. As we learned today, while a pod often contains just one container, it can indeed contain multiple containers that work closely together.
Exactly right, Sheila. And remember, those containers in a pod share the same network space and can easily communicate with each other.
To summarize what we've learned today, pods are the smallest deployable units in Kubernetes, acting as a wrapper around one or more containers. They're ephemeral in nature, have a defined lifecycle, and are fundamental to how Kubernetes manages applications. Understanding pods is crucial for effectively working with Kubernetes.
That's a great summary, Sheila. In our next episode, we'll dive deeper into creating and managing pods, so stay tuned.
Thank you all for listening to Kubernetes Crashcasts. If you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Don't forget to subscribe and rate our podcast. Your support means the world to us. Until next time, happy clustering.